get started. So what we're going to be doing today is a memory leak and showing how to detect it. We're going to be building out a simple app that purposefully has a memory leak, and then showing how to detect it over time and how to narrow down the results. So the first thing we're going to do is I've made just an empty folder for this example app, and we're just going to set up npm really quick. All the defaults, that's fine. So after, what we're going to be using is a couple things. We're going to be using Express, and we're going to be using the cookie session for Express. So same idea as a memory store for cookies. And we're going to use the cookie session, since it's in memory, to cause the leak. So the idea is pretty simple. We're going to copy paste their example, show it works, and then we're going to watch it leak and do stuff. So they have an example set up already. So let's go with their example. So what do we do here? We make it an Express application. We make our session store. We actually don't care about proxies for now. Let's see, what do we got? We got set up some keys, which that's for encrypting cookies. Rotating credentials. We don't need to change that. What do we got? When we get a request, we're gonna increment the number of views. That's kind of neat. That's actually not. When you cause memory leaks in JavaScript, it's generally because you have some sort is being appended to indefinitely. There are a few other kinds of memory leaks, but generally it's something like an array appended to. So what we're actually going to do is change it from a numeric counter here to an array of when you are visiting. So here, actually put a new date so we know exactly when that happened. So can use the same stuff here. This is using use just means it's a generic handler for everything. Let's go with viewed. And then what do we want? We want let's put this in a variable so I don't have to type that multiple times. So for all the views, we're gonna come on a new line. This is going to a browser, so let's do pre because I'm kind of lazy. I don't want to deal with formatting very much. So let's just make sure that this works. So it should listen on 3000. use is not defined. There it is. Every time we're going, it's adding one to our session. You can see we're getting multiple pins every time we refresh. That's for favicons and some other stuff. So it's working. Cool. Let's see here. So we've created a because we have no knowledge about when to start draws. So if I just continued to refresh that page for, I don't know, 20, 30 minutes straight, you'd start to actually impact memory. So the question is, how do we detect this? And how do we figure out where the leaks are occurring? So there's a utility we can pull off npm and install for creating what are called heap snapshots or heap dumps. And that's the current state of all the memory being used by V8 in Node. So we're going to actually install this. Install heap dump, and we're going to save it. And so that goes, it installs some stuff, everything's happy. Get our server so we can actually use that. If the URL. So let's actually make this its own separate handler. So /heap dump we'll use to get. Actually, we don't need to do this. Take snapshot. Then when we're done, let's just next. That looks right. Remove the old snapshots. Cool. Her object is not a function. Oh, we forgot to expose. Or no, that's from the heap dump. I called that wrong. Heap dump. It's like take snapshot, write snapshot, write snapshot. We also forgot to expose the GC. So Node has -expose. What is going on? Let's just jump here. Expose GC index. So now it'll correctly pick that up. So let's take a blank one when the server is just running. So jump up here. Okay, we got our base. We go. Here a couple times, and then we're gonna go to the take snapshot. Line 15 again. Well, that's not good. Will Express doing anything since my days long past? Yeah, I don't know what you're doing. Got a right snapshot. Fires path, domain, overwrite, same name. Da, 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 da. Okay. What do we got here? We got some sort of multiple databases. Let's use this and not Express's normal one. This kind of terrifies me, but I want to see something really quick. It should kappa. Yeah, at 4K it resets because it goes too big. It's kind of gross. It doesn't even warn me. Oh, that's gross. Oh, oh, no. So let's go to something else. Let's use Session Store. What do you got? You got Redis, you got CouchDB, Tinga, Manga, and in-memory store. So it looks good. Change this up. Install it. Copy paste. Well, why didn't you copy? Let's print store, session store, create store. Okay. Let's see how this works out. Kind of light on the documentation, but it probably works the same. Okay, let me restart the server. First session not found. Peer dependencies. Ugh. Most middleware is no longer. Ugh. Okay, so. Back to middleware. I don't want the cookie session. The joys of NPM. When was this last updated? 3 weeks ago. 3 weeks ago. No wonder. Ba, ba, ba. That's just not helpful at all. I don't want to use the cookie store. I want to use the old store, the generic store, the one that let you choose. I wonder, is it just it is. Oh, just out of date docs. Looks like. Hey, there we go. Well, we got somewhere. Lord of the Rings. We got the cookies are staying the same size. Yes, yes. Ah, so now we've got a real memory leak and not bogus memory leak. Group node. This is our process that's running. So we're in the same folder. If we try to kill it with sig user 2, we can see heap dump took a snapshot, which is kind of cool. So let's take a moment and actually take a look at that. Here. I'm actually going to pop this out. So let's go into live coding memory leak. Here we are, 8.6 megabytes. If you go to DevTools under the Profiles tab, what I did was I went to heap snapshot, loaded one. So profiles here, take heap snapshot, we've just pressed the load button. And what you see is a huge heaping wealth of information that's just not useful. Like I can see all the strings here, like the source code of functions. I can see what function closures are currently alive. I can see things like distances of the heap, total number of objects, percentage of memory that they're taking up, the retained size, which is, how to explain that? It's how much memory that the objects are taking up and cannot be garbage collected The shallow size is similar, but it can have shared memory. But if you go and look, you'll notice they're all the same. Basically, I've never found a use for shallow size, but sure. You can see some other interesting things like specifics about how strings are being stored, if they're a concatenated string or not, or if they're stored as a full string. Kind of neat, but this tells me nothing. What's on the heap? What I need to do is I need to make a comparison after a leak. So what we've got here is it's still leaking memory. Not good. We hit it several times. But what we can do is we can take a second heap snapshot, and using that we can create a comparison. So we'll go back to profiles, we'll load up, let's load up a new one as our second heap snapshot. This one's actually smaller, which is fun. So what do we, the UI here is confusing, but you don't want summary. What you want is generally either going to be comparison or statistics. So, or comparison or containment, not statistics. Statistics is fun, but not really something we need. So we're going to compare the heap dump that is our first one with the heap dump that is our second one. And that's cool. So see the size deltas. And this is all the differences, I should say, in the two heap dumps. It's kind of like running diff on the command line. There's a lot of information. It's kind of useful, but there's a trick here. You don't actually want comparison when you're making comparisons, because summary will tell you what was allocated between heap dumps. So what we want is we want what was allocated between the two heap dumps. Nothing. Before the first one? Nothing. So here's the question. Oh, there we go. It just took a while to load up. Yeah, here we are. So what was allocated? Nothing really interesting allocated here. There was some compiled code, so they rewrote some things, probably the JIT. There was some options, kind of cool. So let's see what we want to look at. Objects. Nothing of terrible interest here. What do we got? We got we got something here. Can see what is keeping this alive down here. What closures are currently holding onto it. We see session in there. Let's continue on there. Some stuff. Proto. I got a lot of things named Proto. It's not terribly helpful. URL date. We got one date. Hold up. New date. So all of this is kind of grokking, trying to figure out which function is growing. We've just got too much information. So we're going to do something which will make our lives easier and expose the GC. So how do you do this? Pretty simple actually, and line flag to do it. And we're going to change from SR2 handler to our own handler. Okay, so app.use. We're going to have kind of odd looking thing. So what is this going to do? It's going to try to GC if the GC has been exposed, and then it'll take a heap dump. There's things like we can specify what file to write to and a callback function for when it's done writing, but I don't really want to know. I just want to see it show up on the file system because I want my server to keep running and for sake of simplicity on every request. So let's do request.url equals take snapshot. Then when we're done, let's just next. That looks right. Remove the old snapshots. Cool. Her object is not a function. Oh, we forgot to expose. Or no, that's from the heap dump. I called that wrong. It's like take snapshot, write snapshot, write snapshot. We also forgot to expose the GC. So node has -expose. What is going on? Let's just jump here. Expose GC. So now it'll correctly pick that up. So let's take a blank one when the server. So jump up here. Okay, we got our base. We go. Here a couple times, and then we're gonna go to the take snapshot. Line 15 again. Well, that's not good. Will Express doing anything since my days long past? Yeah, I don't know what you're doing. Got a right snapshot. That should take 3. Move 1. I don't know what was going on there. So let's go and load up stuff in our profile viewer. What do we got? Date modified. We want the one with the smallest to the biggest. So we're in the summary. Everything allocated between. Got some cookie stuff going on. I wonder if it's serializing the cookie. And what's causing issues? Session. Oh, the joy. Pair this with that. Strings. Deleted a ton and got 7. Well, actually, so from our first snapshot, we want to compare to our second snapshot. Stop trying to put that there. Nothing happened. Second snapshot, our third snapshot. Oh no, that's fun. But we do see the dates here. It has to be serializing those. So we see several of these dates. They're coming from a lot of junk. Some anonymous functions. A lot of anonymous functions. In the HTTP. So they are being serialized. That's what was confusing me. I came in thinking I knew what it would look like. But no, the library tricked me. So we can see there's not really much information about this stuff. And part of that is because we didn't name our functions. So let's go and rename them and then check how this works out again. Give them very obvious names. So let's see if we can figure out where this is coming from. Which it would be nice if heap dumps included remotely information about about where those functions are if they're unnamed, but not today. Yes, it is tedious and troublesome to find problems. So we saw some strings that are suspect. What do we want here? We want to find the node instance. Get one. Actually, we did this a little bit out of order. Let's remove all the heap snapshots. There we go, we got 3. Profiles. Let's load them up. So we're looking at these strings because they're suspect. All of these. They're attached to an AP object. They're in properties. Would be really cool if I can see what objects share them. But we can kind of. It should be an array somewhere. So they're all being stored in this array in order. And the array has the same object ID, unique ID. And so that is being kept alive. Views in session. So it's a views property in some kind of session, some kind of session object, which is being kept alive in an incoming meta response. Okay. It's getting more interesting now. Idle next, probably not very helpful. HTTP message. So we've got an array, views on, which is growing. So we got some stuff there. It's a capital A array, so let's go over here. And that's 145. 145.139. Sweet. You can see it. So if we go back in time a little bit. Keep seeing these. So it didn't exist before the first attempt. Gets made here. So from here, it becomes the guessing game of what exactly is going on. We don't know very well which closures causing the leak, but we know what, or I shouldn't say which functions are causing the leak, but we do know where the objects are being stored that are causing the leak. So from here, what you're going to do is actually go back and try to figure out where sessions are being made. There's no real way to tell where these system context, where these actually are, which there are tools I've written to do it, but they're not public, sadly. So we know that that is the leaky problem. It was a little bit rough trying to show how I search for memory leaks, but pretty good. Pretty good. Okay, well, thanks for stopping by, watching me pounded problems, and perhaps not solve them the best, but it worked. Okay, see ya later, everyone.